Hello everyone, I'd like to welcome you to another Dental XP webinar. We're going to talk today about customized 3D treatment planning concepts, matching receptor sites with specific implant designs. And I think we're just about ready to open up the doors to let everyone in. This is pretty unique in the industry, the collaboration with Dental XP and some of the opinion leaders from around the world, which makes it so interesting. And I'm actually coming to you from my home in New Jersey. So before I begin, I'd like you just to jot down, if you would, my website, which is www.drgans.com, and my email address, sdgimplant@aol.com. And you can download some of the articles that I will be mentioning during the presentation. I've published about 65 articles in the literature at this point, and many of them are available on my website, so you can download them. And in fact, many of them are also available on the Dental XP website. Of course, Dental XP has a tremendous amount of wonderful content from various speakers from around the world, and I encourage you to peruse the site and to learn more about some of the other presentations. Of course, this particular presentation is also sponsored by Bar Horizons, and I'd like to thank them and Team Atlanta and Dental XP. So we're going to start today with several concepts, and what I like to do during my presentations is to kind of go over what I call the concepts of myths and realities. Because when we think about many of the concepts that we've learned in the world of implants, and we look at implant to implant distances and implant to tooth distances and where we should put the implant near the bone, near a tooth, near a root. There are many different parameters that are out there today. However, most of them are based upon two-dimensional imaging modalities, and the research that has been done as well is based upon two-dimensional imaging modalities. So we're going to change this focus a little bit and try to look at some of the new paradigms and the new tools that we have today to be able to analyze not only the implant itself, but also what you see here on the screen now, which of course are the connection between the implant and the tooth itself. Because we have to realize that the goal of implant dentistry is not the implant. The goal is the tooth that we're replacing. And so we have the capability of being able to replace the tooth with the implant itself. We have to then look at the connection and the abutment. And so we're going to talk about some concepts that revolve around the tooth position, which if we want to achieve restoratively driven implant dentistry, the tooth position should guide the placement of the implant. And so, therefore, if the goal is the tooth, then we should always have that in mind before we ever touch the scalpel to the patient. And that's really an extremely important point that we cannot underestimate. Depending upon the implant system that we use, we also should look at whether we're going to do a screw-retained or cementable type restoration. And again, this is something that can be planned in advance, and if we plan this in advance in terms of the prosthetic design, then we'll have a more consistent and predictable result. So screw-retained versus cementable should be part of our concept in the diagnosis and treatment planning of our case. And then we can even look at the choice of abutments, because most people don't think about the abutment choice until after the implant is already in. I like to try to think about the abutment before we even place the implant. And so in order to be able to achieve true restoratively driven implant dentistry, we want to be able to achieve that through a combination of diagnosis and treatment planning concepts that I will try to describe to you in this brief amount of time that we have together today. Additionally, of course, we want to be able to maximize function and aesthetics, because our patients want that beautiful look. We want to be able to maintain the soft tissue, and we want to be able to, of course, give our patient back the function that they may be missing because of a loss of occlusion. And so let's talk about how these concepts work. We'll explore some of the different concepts involved around the position of the implant and the position of the implant as it as it neighbors an existing tooth, or in other examples, we have to be able to be concerned about the rotational position of the implant itself. And so when we start to look at an implant like you see here, we're looking at the implant straight down, the occlusal view, and you can see that it has a hex orientation. And so one of the first pearls today is that we want to be able to orient that hex towards the facial. And if we can complete that task in all of the cases that we do, then when we're using an internal hex or we're using some other anti-rotational feature, we'll be able to orient the prosthetic components, the family of abutments that come with any of the implant systems that we currently use. When we take a look at what we call pre-surgical prosthetic planning, these concepts are now, we have new tools, new paradigms to be able to review the pre-surgical prosthetic planning, not just within the realm that we're used to seeing, but also within the realm of the new technologies and new paradigms that we have today. So let's investigate this a little bit further by making a couple of statements that I believe is part of my philosophy. I believe that most implants today are not placed into ideal receptor sites. That means that there's something wrong with the bone, there's something wrong with the tissue, there are things that we have to correct, because most of the time when our patients come in, if they're missing a tooth or they're going to be missing a tooth, there's usually some sort of a defect, there's some sort of bone loss, there's some sort of soft tissue problem that we have to correct. And if we take that as a given, that most implants are not placed into ideal receptor sites, we have to be able to then think about what happens if we go ahead and start placing an implant into these areas. And therefore, the second caveat here is I believe that most implants are not placed ideally. And so we end up with complications. We end up with soft tissue complications and prolongated teeth and all sorts of issues, both in aesthetics and function. And so if we want to be able to maximize our planning concept, we want to be able to achieve the goal of not only having accurate placement, but also being able to have a consistent and predictable result. So let's talk about implant design for a minute, because does implant design have an impact when we're looking at a receptor site? And of course I believe that it does. And this is universal. It doesn't matter what particular system that you're using, but we're going to discuss a couple of different unique features of certain implant design. And you can see here the ability to be, now I'm trying to use my pointer and it doesn't seem to be working, so I apologize. But we can see here on the right side of the screen that we have three different implant shapes. Two of them are bone level, and one of them will be above the bone, going through the tissue as a one-stage type implant. So depending upon the kind of system that you use and the implants that you use, that's going to have an impact on your planning concept. Now in this case, we're going to talk about some of the new concepts involving laser lock, which are microchannels that are placed on the coronal aspect of the implant. And today, based upon some fantastic research that's been done by Nevins and Jack Ritchie and many others, it is really the only surface that shows human histology, which attracts a true physical connective tissue attachment. And so we hope that this will long-term provide a better maintenance of not only the bone, but the soft tissue as well. So how can we plan to use some of the advanced capabilities of an implant system when we're using our diagnostic tools and our three-dimensional tools to be able to assess receptor sites? Because if we think that, again, going back to the statement I made earlier, that most implants are not placed into ideal receptor sites, then you can see here by this diagram that we may have an issue in terms of maintaining the bone after the abutment connection has been made. And we know that every time that we place the abutment on and place the abutment off, that we may disrupt that connection, and we may lose soft tissue, we may lose bone over time. So how can we maximize the effect by implant design and better planning? That's what we're going to talk about. We've seen in the literature that we can have typical amounts of bone loss of 1 to 2 millimeters of crestal bone, and that's somewhat been accepted within the literature. But does that have to happen? And I do not believe that it does. So when we look at some of the treatment that implant manufacturers have done to create a better bone and soft tissue contact, we came up many years ago with a concept from Jack Ritchie and Harry Alexander, two brilliant researchers, to come up with these laser lock microchannels. Now, many people think that an implant is an implant and surface technology really doesn't apply that much, but it really does. And if you take a look at the various surfaces that I'm showing here on the screen, from the blast textured and the SLA surface, the acid etched, etc., you can see that these surfaces are certainly irregular. They're not necessarily consistent. And so anyone that's viewing this, when they start to look at this laser lock microchannels, you can see the uniformity that exists, and also the difference between this type of surface application and the application that you're seeing on the left-hand side of your screen. So all surfaces are not necessarily created equally. And so does this have an impact upon the attachment of bone and soft tissue? I believe it does, which is one of the reasons why I'm using this system right now. So when we take a look at 30x magnification and we compare other manufacturers that have claims that they also have this type of micro channels or macro channels at the coronal aspect of the implant, we can look at the different designs by some of these different companies, and we can see that there are similarities, but yet when we look at this particular system here on the right side of the screen, the laser lock from BioHorizon, you can clearly differentiate the difference in those microchannels. And so you see there's a differentiation between the grooves that are placed on different manufacturers' implants. So when we look at the cellular response, and this is what Jack Ritchie and Howard Alexander were looking at, they were looking at the cell response to these uniform laser lock microchannels. And you can see on the right-hand part of your screen the uniformity of those microchannels. And so that's at 300x magnification. Myron Nevins did some incredible scanning electron microscopy and histology showing this physical connective tissue attachment. What you're seeing here are some of the beautiful images that they've created in the research that has been published. And so if you want to learn more about that, I would suggest that you go to the BioHorizons website, or you can contact Dr. Nevins directly. I'm sure that we can get you copies of that literature. So if we then take these manufacturer design specifications or these changes in surface technology, how can we use some of the new tools to be able to maximize the placement of the implants to take advantage of these new surface technologies, these new microchannels, etc.? And again, you can apply this to whatever implant system that you're using. We're just going to use one particular system today to be able to illustrate some of these points. And so when we take a look at these new paradigms, here's an illustration of one of the implants, and here's a three-dimensional representation utilizing computer-aided software. And so when we start to look at the difference in the right side and the left side, the different color coding, which shows the different diameters of the implants, we can evaluate the actual realistic implant within the receptor site after, of course, we've taken a three-dimensional scan. So we're going to first start out looking at three-dimensional topography based upon either CT or cone beam CT. And so when we do that, as an example, when we look at this particular patient, we look at the existing dentition that you see there, you see that there's a missing lateral incisor tooth. And that lateral incisor tooth that you can see allows us to be able to visualize that missing lateral on the left side of your screen. We can evaluate that receptor site. But just for argument's sake, let's take a look at the patient's right central incisor. The right central incisor exists there. We can see that the bluish type tooth that we have in there. Wouldn't it be nice if we could start to evaluate receptor sites by just being able to choose the implant site size based upon the actual three-dimensional picture of that receptor site? So here we have these new paradigms which allow us to be able to use sophisticated tools such as creating a virtual extraction. So now we have an extraction socket, And within that extraction socket, you can see the narrow facial and the narrow lingual cortical bone. And so as we start to be able to analyze this, we can then utilize our technology and our tools to be able to evaluate that receptor site and start to place an implant there. And so if we then took an implant, let's say, as an example, one that's 3.8 millimeters in diameter, we can evaluate that receptor site and see if the 3.8 millimeter diameter implant would in fact fill that socket for a maxillary central incisor tooth. So if we blow this up a little bit, we can of course see that there's going to be a gap. And that gap distance has been discussed widely in the literature, and it creates a controversy. I mean, how much of a gap can we have? What do we do with that gap? Are we filling that gap, or what are we, how are we handling that? Is a 3.8 millimeter diameter implant appropriate for that particular site? And so we need to be able to take that in consideration. If we then decide we're going to move to a slightly wider implant, one that's 4.6 millimeters in diameter, we then have to consider that we've narrowed that gap in this area, but we've also created a larger base to have an emergence profile from a wider platform, which is a little bit more consistent with a central incisor tooth. And so I call this the restorative dilemma. The restorative dilemma is the fact that we're using implants that are round, and of course the shape of our teeth are anything but round. And so the morphology of our teeth becomes a very important question. Someone has to make up the difference to create a tooth that looks like a tooth. But the problem here is that when we look at this from only one view, we may be missing the entire picture. And the rest of the picture here is the fact that we're looking at now a cross-sectional image through the bone itself. And when you look at a cross-sectional image through the bone itself, you should in fact be able to see some new things. Is this a normal bone contour when we're looking at this cross-sectional side view? And it really, in this case, is not. It's a little unusual because the bone contour actually creates a concavity where the existing teeth is. Remember, we've virtually extracted it. And so here we have a diminished facial plate and we have a diminished lingual plate. And if you take a look where the palatal aspect is, you see the incisal canal. And so we are also now looking at the position of that implant within this alveolus, looking at the facial and the lingual cortical plate. So we're starting to look at the cortices on either side. We can start to observe we can observe the thickness of the cortical plate. We can observe the quality of the bone, the density of the bone, and this also helps us to decide about the implant receptor site. And so if we think that we're obliterating the socket itself with the implant, we are. And so the gap distance actually, you can see on the palatal, is only about 1 to 2 threads. And so we need to be able to understand from different viewpoints exactly what we are seeing in 3D that we can't see in two-dimensional imaging technologies. And so the contours allow us also to be able to make a decision based upon the use of a straight-walled implant or a tapered designed implant. And in this particular case, we're using a tapered design implant to help us avoid the areas of the concavity on especially on the palatal aspect, which may impinge upon the incisal canal. So taking a look at another view, we can see that the socket gap on the facial doesn't even reach the first thread, and so we have to be able to evaluate that as well. So having the ability to look in all the different views becomes extremely important for us to be able to succeed in understanding our receptor site placement in the virtual 3D world. So now if we wanted to use an even wider platform, this one happens to be a 5.8 millimeter diameter implant, we want to be able to evaluate the emergence profile and understand whether or not this would be a better foundation to emerge a tooth, in this case a maxillary central incisor. But if we only utilize this view and we say, oh wow, look at this, there's no gap anymore, well that may be true, and it is true. But what happens on the facial aspect or on the palatal aspect? Because unless we look at all the different views, we may not appreciate the fact that we could be perforating through the facial plate of bone, creating a dehiscence, and in fact, if we're utilizing a drilling sequence instead of osteotomes, we may in fact fracture that bone or it may just disappear entirely. And so to me, that's not necessarily a great solution. Plus, we do have some other concepts like pressure necrosis. And so if we put too much force on that cortical plate, it may just disappear anyway. So how do we choose the correct implant for any given receptor site? And my wisdom here is that every patient is different. Every receptor site is different. And that to me is why three-dimensional imaging technology is so important for us to diagnose and treatment plan properly so that we can place the best implant into this area to avoid complications like dehiscence and pressure necrosis. And so having this capability allows us to be able to choose an implant that's going to allow for good soft tissue maturation, for a good sulcus formation, for a good emergence profile. In this case, we ended up using a 4.6 millimeter diameter implant. But how did we come up with that particular solution for this particular case? Well, of course, we used cone beam CT. We evaluated the bone contours, and of course, some of the contours that we can appreciate in this area are those pioneered by David Garber and Maurice and Henry Salama and many others that talked about the interproximal height of bone. Dennis Tarnow and the NYU group. Well, those pieces of research were all based upon two-dimensional imaging modalities. Well, now we can clearly see the bone contours. We can see the interproximal height of bone on the mesial and the distal of this missing central incisor site. So when we take a look at that interproximal height of bone, which some people call it's almost a mecca of being able to maintain an interdental papilla, well, now we can evaluate this in 3 dimensions and we can understand where that interproximal height of bone is and how to manage that. Because certainly if it's not there, we're going to have a little bit more of an issue in terms of restoring this patient to a good functional and aesthetic result. So 3D planning concepts allow us to be able to not only position the implant itself, but to position the abutment that's going to be the connector between the implant and the tooth. And in this particular case, we're going to use the stock abutment that comes with the implant. We're going to use a concept which I've coined selective transparency. Selective transparency basically means that we're going to take various anatomical landmarks within the 3-dimensional image and we're going to turn the opacity on or off or somewhere in between so that we can see through structures, and in this case we're seeing through the bone and we can see the adjacent root of the maxillary central incisor and the lateral incisor. And so having that capability gives us some new paradigms to understand implant to tooth relationships and implant to implant relationships in true 3 dimensions. So having that capability is really quite exceptional. So the 3D planning concepts here, we're going to use a realistic implant. This is a tapered internal implant from BioHorizons. We're going to use the 3-in-1 abutment that's going to be sitting on top of that implant itself, and that 3-in-1 abutment is going to help us decide what kind of prosthetic connection that we have. And so here we can see the interproximal height of bone. Here we can see the interproximal height of bone. Here's the abutment, and here's the implant. And when we have that capability, we have the ability to be able to plan with these new tools and these new paradigms. So here's the stock abutment. It looks exactly like the virtual abutment that we're trying to place. And so we can connect the implant to the tooth. We can look at the trajectory and the emergence profile, and we can evaluate the fact that we do not have a perforation into this area. So if we take a look at that concavity or the root eminence of this central and the concavity that exists here, we can see that there is a difference in the root eminence of the adjacent structures. And so this becomes very important for us to be able to understand exactly where we're going to go with our restoration. So placing the implant using selective transparency, understanding now emergence profile, allows us to be able to achieve the positioning. But unless we have the missing element here, which is the tooth, how do we really know that we can do a restoration based upon that position of the implant? How do we know whether it's going to be cemented or screw retained? Well, this is the step that allows us to do that. And whether you use a radiopaque barium sulfate type of material, or you use a scanning appliance of other types of construction, or you use software that allows you to create virtual teeth, you have the ability to now assess the occlusion before we ever touch the scalpel to the patient. So this is truly a new paradigm in pre-surgical prosthetic planning. And so here you see the implant, the abutments, and now the virtual tooth in its transparent state, and we can see that right in this area, we can see and evaluate the interproximal height of bone, the contact positions, the abutments, and the trajectory of the tooth itself. And so we can zoom in, we can get a close-up view, we can look at that virtual abutment, and we can start to make some decisions based upon our prosthetic and surgical demands for that particular site. In this case, we may elect to do a screw retain restoration. We may elect to do a cementable restoration. One of the things, of course, that we want to consider is that we want to consider the position of the incisal canal. And here we can see the incisal canal. We can see again the emergence profile now in the palatal. And so having these tools gives us the new paradigms to achieve consistent and predictable results. Now, around 1992 and published first in 1995 is a concept which I call the triangle of bone. And this gives us the ability to create a zone to give us some diagnostics in terms of how much bone is within that triangle to be able to place an implant. And you can download several of the articles from my website, as I had mentioned earlier. A lot of them are also on Dental XP. And in fact, there's a whole video on the triangle of bone concept on the Dental XP website. So you can search for my name or triangle of bone and it may come up.